we're just going to slightly change this problem here. It says, does there have to be a value c in this interval such that, and we're not going to do f prime of c, we're going to do f of c is equal to 0. And so what that means is, look at my f of x values, and this function is continuous and differentiable, okay? So as I go along this interval, is there a time where the function has to have a value of 0? What do you think? Yeah. Why? Yeah, because you go from 16 to -1, right? So in that interval from 1 to 3, you have to cross over 0, right? So all we would write is we would just say yes. And then what we would explain is we would say f of 1, what's f of 1 equal to? 16, and f of 3 is equal to -1. So do you remember what theorem told us that we have to cross over 0? Intermediate value theorem. So you could just write IVT guarantees a value of C. Okay, you don't have to get any more specific than that. I'm going to be pretty lenient on your test. We call this invoking the intermediate value theorem by using IVT. On the AP exam, without a doubt, IVT and MVT are both stated, and you'll get used to doing it. So this is something we bring up now. We'll continue to review as we move forward. All right, so what's different about this? If it says f prime, am I looking for it to cross over 5 here? Or am I looking for the slope of 5? I want you to look and see if you can find a spot where there's a slope of 5. See if you can look and see if there's a slope of 5 anywhere. Okay, a few people saw it. I'm going up 1, right? I went up 1, and here I went up 5. So if I have an average rate of change of 5 over that interval, then that means there has to be somewhere where there's an instantaneous rate of change of 5. So we would say yes. And then we show that there's a slope of 5. So we do f of 1, which is 3, minus f of 0, which is -2. So remember, 3 minus -2 is 5. We'll do that in a second here. Over, what are the x values? 1 minus 0. So I took the top part is the y values. F of 1 is 3. F of 0 is -2. That's the top. And then the x values are in the bottom. Okay, so it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so we've got that. So the top is 3 minus -2 over 1 minus 0. So does everybody understand on the AP exam, they're not going to just want to see 3 minus -2. They would like you to write f of 1, so that you're saying that from 1 to 0, it sits in that interval. It's important that you note that, okay? And we get 5 over 1. So if it deals with slope, is that the intermediate value theorem, or is that the mean value theorem? Mean value theorem. So yes, the mean value theorem guarantees a value of C. A mean value theorem, the mean value theorem guarantees a value of C. Okay, so I'm going to change it. Change this last one to be f of c is equal to 10. Does there have to be a value of c in the interval from, So for people watching on YouTube, looks like I never changed the interval. It should be from 0 to 2. That's our interval. That's our interval. So does there have to be a spot in that interval where the function has an output of 10? No. I mean, the largest value is 6, right? So there's no guarantee that we have to get to. So no, the IVT does not apply. Yes? See, you have a derivative. That means MVT. See here, you don't have a derivative. That means IVT. If it's just the function value, that's IVT. If it's the derivative, that's your rate of change. That's MVT. See that? Okay, flip back to the front of that section so we can actually now state what the mean value theorem says. The mean value theorem starts with conditions. First, the function f has to be continuous and it has to be differentiable. In other words, in higher level mathematics, my professors always used to say, it's a nice behaving function, okay? We would say that this one right here is a nice behaving function. This one's not so nice behaving, okay? Agree with that? So it needs to be continuous, needs to be differentiable. So suppose that a function is continuous and differentiable on AB. Then there must be a value C I'm going to use a shorthand symbol here. Oh, we'll just say in the interval AB. And there must be a value C in the interval AB. Such that sometimes we write stuff down and we don't know what we're writing down, right? Okay, yep, all been there, been there, been there, been there. Good. Try to avoid that. Doesn't mean I do a good job of it. I just try. That was amazing. Can you do that again? Okay. Yeah, I like it. Yeah, that was cool. We need more of that. Okay. So the first part, let the function be continuous and differentiable. Does that satisfy this? Then there must be a value C in the interval. So that means there must be some C between this spot of A and this spot of B. Do you remember what it said? A value C such that? Remember what we said? We said that if you look at the average rate of change, there would be a spot on here where the derivative would be the same slope. Where did we say that happened? You tell me when to stop. Yeah, somewhere right about there if you were to draw a tangent line, same slope, right? So the average rate of change would be the same as the derivative, the instantaneous rate of change. So that's what we needed to say right now. We need to say the average rate of change, which is f of b minus f of a over b minus a. The average rate of change is equal to the derivative at a single point. So that's what we refer to as the conclusion of the mean value theorem. So we've looked at it in 3 different ways. Number one, actually 4 different ways. I gave you like a real life application problem. We talked about a graphical representation. We looked at a table as well, right? So let's do the other piece, which is to look at the algebraic representation. So it says, use the mean value theorem to find equations for the line's tangent. We're not going to do all that. We're just going to find C. We're just going to find C, okay? That's all we're going to do. So I used to carry this out further. We're just going to find a value C, okay? So this is my function. It's over that given interval. Somehow this parenthesis got messed up there. I should really go back and clean up these notes. So we're going to start by doing this part. F of B minus F of A over B minus A. And we're going to show that that's equal to F prime of C. And our goal is to find C in this situation. Is everybody ready? Okay. So F of B. What do I do to come up with F of B? Plug in what? What's my B value up here? 1. So I plug in 1. 1 squared is 1. Make it negative. Negative 1. Minus 6 would be negative 7. Minus. How do I come up with F of A? I plug in the negative 4. What's negative 4 squared? 16. Make it negative. So I have negative 16 minus, and then what's a negative 4 times 6? 24, so it'll be a plus 24. Everybody? Yeah. So it's negative 7 minus what then? 8. So if I plug in a negative 4 here, the negative 6 and negative 4 are going to turn to a positive 24. Yep. Really, you got this? Okay. So then on the bottom we do B minus A. What's B? 1 minus negative 4. Okay. So what do I get in the top? Negative 15. And what do I get in the bottom? 5. So negative 3. So is negative 3 the left side or is it the right side? Which did we do? We just did the left side. Everybody agreed there? Okay, so for the left side, all we found was slope. Agreed? Now we set that equal to the derivative. What's the derivative? Negative 2x minus 6. Can you solve for x? Yes, I would add 6 to both sides, and I get 3 is equal to negative 2x. Divide by negative 2, and we get x, or a value c. C and x are kind of interchangeable. C is equal to negative 3/2. Now, here's something I want to check. Negative 3/2, does that sit between negative 4 and 1? Yes, it does. We just found that spot. For people who are confused about what we just did the same exact thing as what we did right here. When we came up with the slope of this dotted line, we said that was negative 3. When we just solved the equation, we came up with negative 3/2. That was this spot right here. We said that would be, say, negative 3/2. Now, obviously, the curve was different, but that's what we just did. So we've done a graphical representation and an algebraic representation. Good. You kind of got the idea. Looks worse, doesn't it? It's not bad at all. Okay? Nope, don't worry about it. I used to do mean value theorem on steroids. Okay, we would take like 4 or 5 days. We don't have that kind of time, so we do 2 days. Okay? All right? So I need to start with this. F of B. Plug in B. What do you get? 2 over 7 minus everybody agree negative 2? Or is it positive 2? So it's a minus 2. Divided by 4 plus 2. Are we okay with that? Let's use our calculator. I'm going to put the top in parentheses. 2 divided by 7 minus 2 divided by the bottom. I can see that it's 6. And I get negative 0.286 will go. You okay with that? Is that the left side or the right side of the mean value theorem? And when I say mean value theorem, I'm referring to this guy. Okay, so I just figured out that average rate of change. What do I do next? Take the derivative of this. Can somebody think, instead of using the quotient rule, how could I rewrite it so it's not so bad of a derivative? Very good. 2 times x plus 3 raised to the -1 power. That way I don't have to use the quotient rule. What rule could I use instead? Chain rule. Chain rule is beautiful, isn't it? And so I have 2u to the -1, and I have x plus 3. Derivative of x plus 3? 1. Derivative of 2u to the -1. -2 over u squared. Am I okay? All right, so I'm going to say -0.286 is equal to -2 over x plus 3 quantity squared. Looks like a nasty equation, doesn't it? Let's have a fraction over a fraction. How do we solve if we have a fraction equal to a fraction? You could have common denominators. There's another method. Cross multiply. -2 times that is -2. Equals -0.286 times x plus 3 quantity squared. I got caught up watching Gold Rush last night. I told that to Morgan earlier, and she's like, that's such a dad show. I love Gold Rush. It's a great show. What do I do to both sides? Okay, so we're going to take -2 and divide it by -0.286, and I get 0.6993. Can we just go 7? Or do you want to go 6.99? What do you want? 7. Okay, 7 is equal to x plus 3 quantity squared. How do you solve that? Square root both sides? And when we take the square root of a variable squared, we have to list both the positive and the negative. So plus or minus the root of 7 is equal to x plus 3. And what do? Subtract 3. So we got x is equal to -3 plus or minus the root of 7. I think we should figure out what that is. -3 minus the root of 7. And I get that. Is that in our interval? No. -3 plus the root of 7. Is that in our interval? Yes. So the C value is -0.354. Please look back at the original problem. Where is this function discontinuous? Everybody agree -3? So therefore, if my interval said -10 to 10, is my function continuous over that entire interval? No, so we could just say right away the mean value theorem does not apply because it's discontinuous at -3. Okay? But -3 is not part of that interval, so we're continuous over that time, so we're okay. Oh no, how do you do a trigonometry? I'm going to take out my calculator and plug it in. I'm going to plug in 3 sine of x divided by 2. And we can actually figure this out pretty easily. But in case you struggle with it, I'll just show you on the calculator as well. So I have f of b. So what do I plug in first? 3 pi. Anybody know what the sine of 3 pi over 2 is? What's the sign down here? It is -1. If you didn't see that, then you type in 3 pi, and you can see that it will produce, and then multiply it by 3, you can see you get a -3 value. So when you plug in 3 pi, you get -3 minus, I know you'll get this one. If I plug in 0, what's the sign of 0? What is it? What are 0? It's 0. Times 3 is 0. What goes in the denominator? 3 pi. So I have negative 3 divided by 3 pi. So negative 3 divided by, and I'm going to put the 3 pi in parentheses, so I divide everything, and I get negative 0.318. What do I do now? Take the derivative. How do you take the derivative of that? Chain rule. I'm going to have a 3 sine of u on the outside. What should I put on the inside? Yep, or 1/2 x. What is the derivative of 1/2 x? And what's the derivative of 3 sine of u? 3 cosine of u. Remember that was like, that used to be like complicated. Now you guys are easy. That's because you're really smart. I multiply these, I get 3 halves times the cosine of 1 over 2x. I want to solve that. That takes us back to our equation solving days. What do we do to solve this equation? What do you want to move first? The 3 halves, so I can multiply both sides by 2/3. Good. So I'm going to multiply by 2 over 3. And I get negative 0.212 is equal to cosine of 1/2 x. What needs to move first, the cosine or the 1/2? The cosine. How do I move the cosine? I cosine inverse that guy, right? Do you guys remember this option? If I want to pull that, I could go second answer, and it just puts that right in there. Okay. And I get 1.78 is equal to 1/2 x multiplied by 2. And I get C is equal to 3.569. So I cosine inversed this value, and that produced 1.78. Everybody, when you get this, is this between 0 and 3 pi? Because 3 pi is over 9, isn't it? So you're definitely there. Good job. Last one. F of b, what do I plug in? 9. 9 minus 1 is 8. What's the cube root of 8? Times 2 is 4. Minus 0. Divided by 8. And you get 1/2. So we got the left side just fine. Let's do the right side. What do I have to do with this? Chain rule. How do you want to write the chain rule? Let's start with the inside. What's the inside for the chain rule? X minus 1. So now what's the outside? 2u to the 1/3. Good job. You guys are doing great. Mean value theorem isn't easy. So you're doing a good job. Derivative is 1. Derivative of 2u to 1/3. 2 over 3u to the 2/3. So I get 2 over 3 times x minus 1 to the 2/3 power. How are you going to solve that? Sure, cross multiply, that's fine. 4 equals 3 times x minus 1 to the 2/3. Now what? Divide by 3. 4 over 3 is equal to x minus 1 raised to the 2/3 power. How do I get rid of the 2/3 power? Kind of a tough one, isn't it? Nice and loud. You cube it and then do the square root. you raise it to the reciprocal power. You see that? If I raise this, think about it, if I raise this to the 3/2, a power to a power you multiply, right? And that would just give me 1. So raise that to the 3/2. So we got to figure out that on our calculator. Fortunately, we've got these excellent calculators. We can do 4/3 and raise that to the 3/2. And we get that thing, 1.539. And finally, what to do to finish this off, other than add 1, we get C is equal to 2.539. Is that in our interval? Is that in our interval? It is. And so the mean value theorem comes true again. Thank you. And that is that. Okay? You are ready to proceed with the rest of your mean value theorem worksheet. What I want to turn your attention to is this. Oh, never mind. Yes, that's that. Oh, these are the notes. Worksheet. Great. Yep, nope, you're set. I was wondering if I put some AP examples after that. I have them in your notes, and we're going to look at that on at a later time. All right, rest of the time is yours.